Hello. So for this week, I will be starting with question 2, which states 250 grams of water is heated over a canister that contains 4.5 grams of propane. Temperature of the water increases from 65 degrees to 70.8 degrees. The mass of the propane after heating the tank has a mass of 4.38 grams. Calculate the fuel value in propane. So there's a couple of givens for this. Our first is going to be propane. Our second is going to be temperature. So the first thing I'm going to do is calculate the amount of propane which is burned, which, like I said, is given. So we're going to subtract 4.38 from 4.5. So the amount of propane burned is going to be 0.12 grams. Next, we're going to determine our temperature. Our final temperature of 70.8 minus our initial temperature of 65 degrees leaves us with 5.8. We know that our heat equation is heat equals mass times specific heat times temperature. So we're going to take 250 grams of water times the specific heat of water times the temperature, which gives us 6,066 joules. We're then going to convert that into kilojoules by dividing it by 1,000. Next, to determine the fuel value, we're going to take that number, 6,000 kilojoules, and divide it by the amount of propane which was burned, which gives us 50.557 fuel value. Now, moving on to question 3. If 155 grams of propane reacts with 635 grams of O2, find the limiting reactant. So, to start this question, I'm going to write down our given equation. And then we're going to find the molar masses of both of our reactants, so oxygen and propane. After doing all the addition, the mass of propane is going to be 44.10 grams per mole. The mass of oxygen is going to be 32 grams per mole. Our next step is we're going to want to find out how many moles of each substance we have. So we're going to take 155 grams propane, divide that by 1 mole, and we're going to get 3.51 moles of propane. We're going to do the same thing for oxygen. 635 grams of oxygen divided by 1 mole of oxygen leaves us with 19.84 moles. Now, because there are 5 oxygens for every 1 propane, this would make propane the limiting reactant. Let's see, moving on to question 4. Calculate the mass of H2O produced based on your answer to number 3. So for this question, again, I have written out the given equation, balanced equation. So for this, we know that 1 mole of propane here converts into 4 moles of oxygen. So we're going to take our given, which is, I'm sorry, not our given, our calculated 3.51 moles of propane. We're going to multiply that by 4 moles of oxygen. That's going to give us 14.04 moles of H2O. Then we're going to convert our moles to our mass. We know that the mass of H2O is 18.02 grams per mole. We're going to take our 14.04 moles of H2O. We're going to multiply that by the molar mass of H2O, and that's going to give us 253 grams of H2O. Moving on to question 5. The reaction described in number 3 is carried out in lab and 245 grams of water are recovered. Calculate the percent yield of water. This one is probably the easiest question. So we're going to take our formula for percent yield, which is actual yield over theoretical yield times 100. So we know that our we know that our actual yield was 245 grams, and we know that our theoretical yield was 253 grams. We're going to divide those, multiply it by 100. That gives us 968.4, but we know it's a percentage, so we're going to move the decimal over to 96.8% yield. Now, Moving on to the last question, question 6. Based on your answer to number 3, calculate the amount of heat produced. Again, this one is very straightforward. We know that the enthalpy, I hope I said that right, was given for propane combustion. It was negative 2,220 kilojoules per mole. We know that the equation for heat is heat equals mass times specific heat times temperature. So we're going to take 3.51 moles. We're going to multiply that by our specific heat of 2,220 kilojoules per mole, which is going to give us an answer of 7,792.2 kilojoules. Thank you.